Good day, class. My name is Iwale Matthew. I'm still teaching you mathematics. We shall be moving to mensuration today as our topic. Then under it, we shall be looking at length of arc of circle and perimeter of sectors and segments. Let's first look at the meaning of arc. The meaning of arc. Arc is the curved part of a circle. Is the curved part of a circle, or is the curved part of the circumference as well. So when you look at this curved part, that is an arc. So we have, it is now categorized into two. We have the major arc and we have the minor arc. So you can see here that is larger than the other one is the major arc, and the curved part that is not as large as the first one is known as minor arc. So hence, an arc is a length or a distance along the circumference of a circle. That is, it is the distance between ear to ear, or from ear to ear. So when we are talking about an arc, is the distance along the circumference of a circle, and it's never an area. It is not area. It's just the measurement, the distance between the curved part of the circumference. Now, what do we now mean by a sector? A sector is a region. A sector is bounded by two radii and an arc. So you can see this is a radii, this is another radii, the radius rather. So the two is now categorized as radii. When it is one, it is radius. So when the radius is more than one, then it is radii. Then this is the curved part, which is the arc. So it means a sector is made up of two radii and an arc. So hence, an arc is a length, whereas the sector covers an area of a circle. So you can see arc is the length, where the sector covers the area at which we are talking about. Then what do we now call a segment? A segment of a circle is the part cut off from the circle. So if you have a circle, if I have a line from the circumference of the circle to another part of the circumference of the circle, this particular region is known as a segment. So where this larger space is called the major segment. So we have the major segment and we have the minor segments. So a chord is the line segment AB. So you can see this is a chord. A chord is a line, but a segment is a region in a circle. So it's the space. This space is known as the region, while the line AB is known as a chord. Then let's now go to the length of arc of a circle. How do you get the length of an arc of a circle? So let me go straight forward here. The formula for finding the length of an arc, the formula is this, which is length of an arc is equal to theta over 360 degrees multiplied by 2 pi r, where theta is the angle that is being subtended, and r is the radius of the circle, and pi, you know the value of your pi. Your pi can be 22/7. So if 5 sectors are cut off from 5 different circles, and the length of the arcs, L, radii, R, and angles measured and compared, that is, if you have 5 circles together, so then that will be length over 2 pi, which is the circumference of the circle. That will be the length over 2 pi, which is equals to the angle it occupies over the total revolution, which is 360 degrees. So from here, make L the subject of the formula from here. So that will give you L is equals to theta over 360, then multiply by 2 pi r. So my length of an arc is equals to 2 pi r theta over 360 degrees, which is still the same thing as this formula. So what I just want you to learn from here is the formula finding the length of an arc is theta over 360 multiplied by 2 pi r. Now let's look at one or two examples. Find the length of an arc of a circle of radius 5.6 centimeter, which subtends an angle of 60 degrees at the center of the circle. Take pi to be 22 over 7. So from this example, we have been given the radius to be 5.6. We have been given the angle that is being subtended to be 60 degrees. So just apply your formula. So we have the formula is length of an arc is equal to theta over 360 multiplied by 2 pi r. We are given the theta to be what? To be 60 degrees. Then r to be 5.6 centimeter. Then pi to be 22 over 7. So substituting these values into your formula. So the length will now be theta, which is 60 over 360 multiplied by 2 times pi, which is 22 over 7, then multiplied by 5.6. So here is 0 here. In this 0 cancel 0. 6 going 6, 1, 6 going 36. That is 6. So I have 1 over 6 times 2 times 22 over 7 times 5.6. So from here, multiply the numerators. That is 1 times 2 times 22 times 5.6, which will give you 246.4. Then divided by the denominator, which is 6 times 7, which is 42. So when you divide 246.4 divided by 42, you have 5.8667 centimeter. So and then you approximate your answer to 2 decimal places, which is 5.87 centimeter. So the length of the arc is 5.87 centimeter. That's for the example 1. Now for the example 2. What angle does an arc 6.6 centimeter in length subtend at the center of the circle of radius 14 centimeter? Use pi to be 22 over 7. So here in this example 2, we are looking for the angle. So we still follow the same formula, which is length of an arc is equal to theta over 360 multiplied by 2 pi r. So we are given the length to be 6.6 centimeter, which is equal to theta over 360. The theta is what we are looking for, which is representing the angle. Then times 2 times pi, which is 22 over 7. Then times the radius, which is 14. So then after that, clear the denominator. So from here, looking at this step, so if I want to look at this step, this is the same thing as the denominator you cross multiply. That will be theta multiplied by 2 multiplied by 22 multiplied by 14 is equals to 6.6 multiplied by 360 degrees multiplied by 7. So that is cross multiplication from there. Then when you multiply everything, divide both sides by what is beside your theta, which is 2 times 22 times 14. So divide both sides by 2 times 22 times 14. So what are you having left? You have your theta left. So your theta is equals to 6.6 times 360 times 7 all over 2 times 22 times 14. So when you multiply the numerator together, you have 16,632. Then your denominator, we have 2 times 22, that is 44. 44 times 14 will give you 616. So divide 16,632 by 616. So you have 27. So it means the value of your theta is 27 degrees. So the angle it subtends is 27 degrees. Then the example 3. Example 3. An arc of length 12.57 centimeters subtends an angle of 60 degrees at the center of the circle. Find the radius of the circle. Then 2. Find the diameter of the circle. So here in this example 3, we are given the length and we are given the angle that is being subtended. So we are looking for the radius. We still apply the same formula, which is the length of an arc is equal to theta over 360 multiplied by 2 pi r. So we are given the length of the arc to be 12.57, which is here. Then is equal to theta, which is the angle given to us, which is 60 over 360 multiplied by 2 times 22 over 7 times r over 1. So here I can also cross multiply from here, which is from here rather. So if I cross multiply from here, so I will multiply the numerators together. That will give me, don't forget I'm looking for r. So that will give me 12.57, which is here, multiplied by the denominators. Don't forget when I cross multiply, it means this will multiply this will multiply 1. So that will be 12.57 multiplied by 360 multiplied by 7 multiplied by 1 is equal to the angle, which is 60 times 2 times 22 times r. So 12.57 times 360 degrees, that will give you 31,676.4. Then is equals to 60 times 2 times 22. That will give us 2,640 times r. That will give us 2,640 r. Then divide both sides by 2,640 to get your r. So 2,640 cancel 2,640. You have r is equals to 31,674.4 divided by 2,640. So when you divide it, you have 11.9986. Then approximate your answer to the nearest whole number. So 9 is up to 5. So you round it off to 1. So 1 plus 11, that is 12. So it means the radius is 12. Now to look for my diameter, don't forget my diameter is equals to 2r, which means in a diameter you have 2 radius. So that will be, my diameter will now be 2 multiplied by the radius, which is 24. So I left that one for you to finish on your own. So it's what I have explained. So your diameter there will be 2 times r, which is 2 times 12, which is 24. So the diameter there will be 24 centimeter. So let's move to the last example under the length of an arc. An arc of an angle of a circle of diameter 28 meter subtend an angle of 108 degrees at the center of the circle. Find the length of the major arc. So it means the minor arc is 108 degrees. So to look for your major arc, don't forget the total angle for the revolution. That is, if I have a circle, if this is the arc, if I have a circle, then if my arc is like this, if this angle is 108 degrees, which is the minor arc, so my major arc will be the total sum of angles meeting at the point, which is 360 degrees, minus the minor arc, which is 252 degrees, So here, so I have theta over 360 multiplied by 2 pi r. Then don't forget we are given diameter from this question, and our diameter is 28 meter. So to get my radius, just divide this by 2. So that is 2 into 1, 2 in 8, 4. So that is 14 meter. My radius will be 14 meter. So here I have the length, which is not given, is equal to theta, which is 252 times 2 times 22 over 7 times 14, because the diameter is 28, so I've converted the diameter back to 14. So I have 252 times 22 times 14. Or I can even divide from here. I can 2 go in 2 here, 1. 2 go in 360, that is 180. So that is 180 degrees. Then multiply this out. 252 multiplied by 44. right, divided by 180. Why? Because 7 also go in 7 1, 7 go in 14 2. So 2 go in 2 1, 2 go in 360, 180. 7 go in 7 1, 7 go in 14 2. So I have 252 times 22 times 2 all over 180, which is 252 multiplied by 44. That will give you 11,088 divided by 180. That is 61.6 meter. So the length of the major arc is 61.6 meters. So that is for the length of an arc. Now let's go to perimeter of a sector. Don't forget, I've told you that a sector is bounded by 2 radii and an arc. And don't forget, the word perimeter means the addition of all the side the shape is occupying. But here we are talking about a circle now. Don't forget, and the formula for finding the perimeter of a circle is 2 pi r. So the word perimeter simply means the distance around an object. So the perimeter of a sector of a circle is the distance round this circle. So hence the perimeter of a sector AOB. Now if I want to look for perimeter of AO, here is O, then B, is the sum of the 2 radii, which is the radius here, of the arc, and the radius of this length, which is L. So where R is the radius and L is the length of the arc. So from there, the formula of finding the perimeter of a sector is theta over 360 multiplied by 2 pi r plus 2r, which is the 2 radius. So you can see the formula of finding the length of an arc is theta over 360 multiplied by 2 pi r. But when it comes to perimeter of a sector, you add 2r to the formula for finding the perimeter of a sector. So example 1. We are also looking at 2 or 3 examples under this before we end our class for today. So example 1. Find the perimeter of the sector of radius 3.5 centimeter which subtend an angle of 45 degrees and an angle of 315 degrees. So taking our formula to be theta over 360 multiplied by 2 pi r plus 2r. So here we are given our theta to be 45 degrees, then our radius to be 3.5. So and our pi, don't forget your pi will be 22 over 7. Once you are not given a value of a pi in your question, just note that the value of your pi will be 22 all over 7. So from there, I have 45 over 360, which is theta over 360 times 2 times 22 over 7 times r, which is 3.5. So from there, don't forget our 2r. That will give us 7. Now, from here, I will also have 45 go in 45, 1, and 45 go in 360, that is 8. So I have 1 over 8 times 2 times 22. Then, my 2r, here, I have 2r plus 2r. My radius is 3.5. So convert this. That will give you the 0.5. So I have 2 times 22 times 0.5, which will give me 22. Don't forget 2 times 22 will give me 44. Then 44, 0.5 is same thing as 1 over 2. So which is what? Which is 22. Then all over 8. So it means the perimeter is what? Is 2.75. So if I have 2.75, then plus, so here you are going to add this one to it on your own. So that's why I left some of the workings, so I know those of you that are reading this. So that will be 2.75 plus my 2r. I did not add 2r. When you look at the workings I've done here, I did not add 2r. So that is 2 times the radius, which is 3.5, which is 7. So add 7 to this, that will give you 9.75. So my radius, the perimeter will be 9.75. Then for the second angle, which is 3 115 degrees. So we still apply the same formula, which is 2r plus the length of the arc. We have gotten the length of the arc, so just add to it. So this is, I've added the arc here now. So this is the continuation of the last the example 1. So I've gotten the value here. So here I'm adding the length of the arc to the question. So now go to the example 2, where we are given an angle of 315 degrees. So also look for the value of the length of the arc before looking for the perimeter. Once you look for the length of the arc, just add 2r to the answer. That is 315 over 360 multiplied by 2 times 22 over 7 times 3.5 centimeter, where 3.5 is the radius and 22 over 7 is the value for pi. 315 is the value of our theta. So that is 315 times 2 times 22 times 3.5, which will give us 48,510 centimeter. Then over 360 times 7 will give us 2,520. So divide this, you have 19.25 centimeter. So the perimeter, just add 2r. Don't forget that will be 2 times 3.5, which is 7. So 7 plus 19. So that will give you 26.25. Now let's now move to perimeter of a segment, which is the last aspect we are going to touch for today's class, for this week class. And the perimeter of a segment is theta over 360 multiplied by 2 pi r plus 2r sine theta over 2. So here, what you just need under this is just to know the formula for finding each of these. The formula for finding the length of an arc is theta over 360 multiplied by 2 pi r. And the formula for finding the perimeter of a sector is theta over 360 multiplied by 2 pi r plus 2r. Where the formula for finding the perimeter of a segment is theta over 360 multiplied by 2 pi r plus 2r sine theta all over 2. So now look at the first example here. We have AB is a chord. AB, you can see, this is line AB. When you look at AB very well, AB is a chord of a circle with center O, where the center is O. And radius 4 centimeters. The radius for this is 4 centimeters each. And the angle AOB is what? Is 120 degrees. Calculate the perimeter of the minor segment. So here we are looking for the minor segment where the angle that is being given to us is 120 degrees. So in solving this now, our chord is r sine theta over 2, where our r is equal to 4 radius and our theta is 120 degrees. So the first thing I will first look here is to get the value of my theta, sine theta. So here I can say that theta is 120 divided by 2. So here I have sine 60 degrees. So applying the formula now, I have 2 times 4 sine theta, where 4 is the radius, sine theta. Don't forget, I've not added the, let me take you back a little bit. This is the first thing I look at now. I look for the value of 2r sine theta. Don't forget my r radius is 4 centimeter, and my 2 is constant. So going back here, I have what? I have theta over 2, which is 120 divided by 2, which will give me 60 degrees. So taking the 2r sine theta over 2, taking this first before going to the length of the arc. So that will give me 8, 2 times 4, 8 sine 60 degree. And sine 60 degree will give us root 3 over 2. Applying your trigonometric ratio that we did in our last class. So that will give you, now here, 2 go in 2, 1, 2 go in 8, that is 4. So it means I have 4 root 3. So and when you press 4 root 3 on your calculator, you have 6.92 centimeter. So it means that is for that. Now to get the length of the arc, that is theta over 360 multiplied by 2 pi r, where my theta is 120 degree multiplied by 2, then times my radius, which is 4, then multiply by my pi, which is 22 over 7. So multiply all these numerators together. That will give you 120 times 2, that is 140. 140 times 4, then times 22, which is 21,120. Then divided by 360 times 7, that is 2,520. So divide 21,120 by 2,520. That will give you 8.38 to 2 decimal places. So don't forget, I've gotten the value of this to be 6.92, this to be 8.38. Then the perimeter will now be add the two together. That will give you 8.38 multiplied by plus 6.92, which will give us 16.30 as an answer. So the perimeter of the minor segment is that. But if the question asks you to look for the major segment, it means you subtract 120 from 360 degrees. Then you solve it the way we solve this. So this is the end of our class for today. Please, if you have any question, don't hesitate to ask me question. So today you are having 3 class activities, so which I'm expecting by Thursday, latest by Thursday. So please make sure you submit it, and when you want to send it, make sure it is clear when you are snapping the solution. And please make sure you write your question before you start solving the solution. So question 1, calculate the perimeter of a sector of circle of radius 14 centimeter, where the sector angle is what? Is 60 degree. Here you are looking for the perimeter of a sector. Perimeter of a sector, which is theta over 360 multiplied by 2 pi r plus 2r. Then the number 2, the perimeter of a sector is 61.43 centimeter. If the angle subtended by the sector at the center is 120 degree, find the radius of the sector. I've done this kind of example as well. Then the last question, an arc AB of a circle radius 4.8 centimeter subtends an angle of 158 degrees at the center O. Find the area of the sector. Find the perimeter of the sector. That is an error. Find the perimeter of the sector. Then B, find the perimeter of the minor segment cut off by the chord AB. So I am expecting it by Thursday, and please stay safe and stay at home, and you are blessed in Jesus' name. Bye.